So now in this short, we have a current source using a PNP bipolar junction transistor. There you can see we got about 10.3 milliamps of current, but I made this to get about 10 milliamps of current. Now that will be the same even if we change the load, as long as we have enough voltage to power everything. So we got an LED there. We have to complete the path again to get that current, but there you can see basically about 10.3 milliamps of current, about 10 milliamps of current. That's the main thing. So we have a red LED there. A 10,000 ohm resistor is letting current flow through there, so that you build up about 1.7 volts because it's hardly any current. Then you have a 100 ohm resistor over here. So we're going to get about 1.7 volts less than the positive supply voltage to the base, and then we're going to lose about 0.7 of that from base to emitter there, putting about 1 volt across a 100 ohm resistor, giving us about 10 milliamps of current. So now here's my schematic diagram for a PNP bipolar junction transistor right there. Doesn't really matter what you use, but pin layout will vary with different ones. But in any case, the emitter side, we got a 100 ohm resistor. Here we have a red LED in series with the 10K resistor right there. So it's going to pass a little bit of current, but hardly any. So we're going to get, basically the bare minimum forward voltage of the LED, probably about 1.7 volts. Now that's to the base. The emitter, you're going to lose about 0.7 of that volts in relationship to the positive supply. So that's going to put about 1 volt across this resistor right there. The transistor is going to pick up the rest, as is the load. With no load though, the transistor will take all that extra voltage. You'll get that 10 milliamps of current that you set there. If we put a red LED, or any color LED, doesn't matter. The current is set there as long as we got enough voltage to power everything. So we'll still get about 10 milliamps of current.